this lesson is from Mrs. Cucci's College Now PreCalculus class. Today we're going to be talking about matrix operations. Our objectives are to be able to add, subtract, and multiply matrices when possible, and also write a matrix of two systematic equations. So this will be 2 days. We'll split this lesson in half. Okay, so adding and subtracting matrices. In order to add and subtract matrices, we have to add or subtract the corresponding entries. For this to be possible, the matrices must have the same order. Okay? So if I have two matrices M and MN matrices, their sum is going to be just like that, your difference change here. I know that it doesn't really make any sense, but once you see how this is done using the matrices, it's much easier. Okay, so let's actually take a look at that, okay? Alright, so addition of matrices is both commutative and associative. So let's look at A. We're going to add these matrices together. Your first matrices is 2 by 2. Okay, so there's A. And B is also 2 by 2. So to add these together, you're adding together their corresponding parts here. Okay? So when we add these together, we're going to add these two. So negative 5 plus 6. And then you're going to add these two. 0 plus a negative 3. And then these two. 4 plus 2. And then these two. 1/2 plus 3. Simplify this out. We get 1, negative 3, 6, and 3 1/2. So adding together two 2 by 2 matrices gives us a 2 by 2 matrix. Okay. So let's look at a second example of this. We have matrix A. 1, negative 1, 6. 3, 5, 0, and matrix B, negative 1, 1, 3, negative 2, negative 2, 1. These are 3 by 2 matrices, 3 columns, or 3 rows, 2 columns. So let's go ahead and add these. 1 plus negative 1, 3 plus negative 2. Negative 1 plus 1, 5 plus negative 2, 6 plus 3, and 0 plus 1. Which is going to give us 0, 0, 3, 1, 3, 1. Which gives us, again, a 3 by 2 matrix. Okay, so now let's talk about subtraction. So we have matrix C, matrix D. 1, negative 2, negative 3. 2, 0, negative 1. And matrix D is 1, 2. Negative 1, 3, 3. And if we're subtracting, just like when we're adding, you're subtracting the corresponding parts. So 1 minus 1, 2 minus a negative 1. Negative 2 minus 1, 0 minus 3, negative 3 minus 2, negative 1 minus 2. So when we do subtraction here, 0, 3, negative 3, negative 3, negative 5, and negative 4. This should be pretty easy. So we'll try one more subtraction. 2. Here's matrix D, and that's a 2 by 1. 2 by 2, 2 by 1. Okay? You can't actually subtract these because they don't have the same order. One's a 2 by 2, one's a 2 by 1. So it can't be done. These do not have the same order. Alright, so there's adding, there's subtracting. Let's go a little bit further here. So now I want to find negative A or A plus negative A. So if I want the negative of a matrix, all you're essentially doing is changing the values within that matrix, or like multiplying them through by negative 1, right? So if matrix A is a 2 by 3, 1, 0, 2, 3, negative 1, 5, and I want negative A, all you're going to do is go ahead and change these. So I want negative A plus A. Remember, addition is commutative, so I can go ahead and just add A. We add their corresponding parts. So negative 1 and 1, 0 and 0, negative 2 and 2, right? A and negative A are inverses of one another. What happens when you add something's inverse? We wind up with all zeros, right? We know that. You add something to its inverse, you're going to end up with the additive identity. That's called the additive identity, right? Okay, so if that's the additive identity, the zero matrix is the additive identity. So a matrix having all zeros is called the zero matrix. When a zero matrix is added to a second matrix of the same order, the second matrix is unchanged. That should make sense. The zero matrix is an additive identity. And again, you add zero to anything, it's not going to change it. Okay? So it's the additive identity. So, for example, if I have the 2 by 3 matrix, 2, 3, negative 4, 0, 6, 5, and I add to it the zero matrix, you're going to get your original matrix back, right? It's unchanged because we added the additive identity to it. Okay? All right. The lesson we're going to talk about today is scalar multiplication. Scalar multiplication is when we find the product of a number and a matrix. We obtain what's called the scalar product. A scalar product of number k, so that's some constant, and a matrix A, is the matrix denoted Ka, obtained by multiplying each entry of A by the number K. The K is called scalar, and that's important, okay? Your K, your constant value, is what we call scalar. Okay? That's why we call this scalar multiplication. So let's see how this actually works. We want to find 3A and negative 1A. When the matrix A is a 2 by 2 matrix, 3, 0, 4, 5. All right, so let's start by finding 3A. So all you're doing here is you're taking each part of this matrix and you're multiplying it by 3. So negative 9, 0, 12, 15. And if we want -1 there, we just talked about this, right? It's the inverse of it. So all you're doing is multiplying through by -1. 3, -4, 0, -5. So very, very simple. Okay. We do have a bunch of properties of matrix addition and scalar multiplication, and we're going to talk about those. That's what we're going to do today. Alright, so properties of matrix addition and scalar multiplication. For any m times n matrices, A, B, and C, and scalars K and L, A plus B equals B plus A, and we know that that's a commutative property of addition. A plus quantity B plus C equals the quantity of A plus B plus C. We know that is the associative property. Addition. KL times A is equal to K times LA. That's the associative property of scalar multiplication. And just by looking at this, you should know this is the distributive property. So that means if I take the sum of matrix and then multiply through the scalar, it's the same as multiplying the scalar through each matrix prior to taking the sum. And then this is also the distributive property. So you need to pause this video here so that you can get this down, please do so. So there also exists a unique matrix 0 such that A plus 0 equals 0 plus A, which is A. And that's your additive identity property. And then last but not least, there exists a unique matrix negative A such that A plus negative A equals negative A plus A, which is 0. And that's your additive inverse property. Actually, let's do this last problem, and then we'll call it done. All right, so here we have a production problem, so this is one of our real-world applications. Waterworks manufactures 3 types of kayaks and makes 2 plants. The table below is the number of each style produced at each plant in April. Okay? So we have a whitewater, we have an ocean, we have a crossover. And then we have the Madison plant and Greenberg plant. Part A asks us to write a matrix A that represents the information in the table. Part B wants us to find a matrix that represents the increase in production, since the manufacturer increased production by 20%. Okay. Part C wants us to find A plus M, so we're adding those matrices together, and then describe what it represents. So our first step is to actually create a matrix based on this information here. And that's actually pretty simple. All you're doing is you're taking the values that are there and you're putting them into matrix form. And we're calling it matrix A. Okay? So we have 150, it's a 2 by 3, 120, and 100. And then we have 180, 90, 130. So it's a very basic matrix, straight from the data that's given to us. So the next thing that we want to look at, part B says, we're increasing production by 20%. So we want to find a matrix that represents that increase in production. So if I know I'm increasing it by 20%, what I'm actually doing is I'm taking my original A. And I'm adding it to a 20% of itself, right? So I'm finding out what 20% of each value is, and I'm adding it back to my original. I'll put it at 20%. Okay? So we can use scalar multiplication here. I know that this is A plus 0.2A, right? 20% is 0.2. So this would be 1.2A. So we can use our scalar multiplication to determine that matrix M. So if I want matrix M, I have to do scalar multiplication. 1.2 is my original matrix. 150, 120. Oops, I was doing that. Okay. Multiplication, when I multiply each one of these through by 1.2, it's going to give me 180, 144, 120, 216, 108, and 156. Okay. So the last part of this wanted us to find the matrix A plus M and then tell what it represents. So we can pretty easily determine what A plus M is. This right here is our A. Here is our M. So A plus M, we're going to add those corresponding values, right? 150 plus 180 is 330. 120 plus 144 is 264. 100 plus 120 is 220. 180 plus 216 is 396. 90 plus 108 is 198. And 130 plus 156 is 286. So there's our sum of our two matrices. So what in the world does that represent? Well, what it represents is the total production of each of the three types of kayaks in April and May. Don't mind that, I can't make it go away. Okay. So that's an application problem using addition of matrices. Alright, so in the next video we're going to talk about the product of matrices, but make sure you come with any questions that you may have in this material, and I will see you tomorrow.